As my title suggests, I'd like to speak with you today about looking at Earth. I've been looking at Earth for as long as I can remember, from a childhood fascination with maps to making maps as a geologist and oceanographer, and on to operating a constellation of Earth-observing satellites. I've had the rare opportunities of looking at our planet from a spacecraft more than 200 miles above the Earth and a submersible over 1.5 miles below the surface of the ocean. Two very unique perspectives, to be sure. But the technological and scientific advances of the space age and the computer age have actually allowed all of us to see this planet from some remarkable new perspectives in the last decades. We are the first generation of human beings to experience Earth this way. We are the first to live with a digital globe and figure out what that means. Of course, humankind has been looking at Earth in many ways since the very dawn of our history, and representing those perspectives in some marvelous forms. Many of the early imaginings are remarkably sophisticated, considering the limited tools and information then available. I would say when we truly look at Earth, we see both planet and place, the natural and the constructed, in a sense, the past, the present, and the future. Both the absolute wonder and the utter insignificance of our place in the universe. It is said by wise people that friends don't let friends do PowerPoint. Nonetheless, I will use it today to share with you some spectacular images of our planet. These will range from a map by an early first-century geographer to an image released just 2 weeks ago from what is called the most complete digital topographic map of Earth. Some of my personal favorite views from the Space Shuttle and International Space Station programs will round things out. I offer all of these as both geography and art, as practical and fanciful, informative, inspirational, and intriguing, for you to enjoy on many, many levels. My hope is that they amaze, delight, and intrigue you, that they instill in you a sense of wonder and curiosity about our home planet, that they raise your appreciation for the tremendous benefits we have reaped from looking at Earth through technological eyes of the space age, and remind you how essential this capability is now to our individual, daily, personal, and economic lives. Finally, I hope these images fire your resolve to better understand and better care for the remarkable blue marble on which we live. Before I talk about the beginnings of mapping the Earth, however, let me share a little bit of my own personal geography and the roots of my passion for maps. I grew up in greater Los Angeles in Woodland Hills, California, the hills being the foothills of the Santa Monica Mountains. We lived about 20 miles from the ocean. To be more geographically precise, I grew up in the San Fernando Valley. So technically, I am a girl from the valley. But let me assure you, I am totally for sure like not a valley girl. From my earliest childhood, I loved maps, starting with the kind you used to be able to get for free from the gas stations. When I was 7, my parents decided to take a family trip to a cabin at Lake Sabrina in the Sierra Nevada mountains. I dug the road map out of the glove box, found Lake Sabrina, looked up the coordinates, and located the spot on the map. This is the place we're going to go, my first trip to the mountains. Curious how this new place, this dramatic new place, connected to my place at home, I then traced my way along the roads and highways back to our house. As we left the driveway on vacation day, my dad asked my mom to pull out the map and figure out which highway to take. They chuckled when my little 7-year-old voice piped up from the back seat, "395 will get you there." Their amused chuckle turned to shock a few minutes later, though, when my mother announced, "She's right." I couldn't wait to browse the latest issue of Life magazine and National Geographic when it arrived in our mailbox, to see exotic locales and people who didn't look just like me. I pored over the accompanying maps and squirreled them away in my bedroom. I searched the family atlas for any new place I heard about and looked up all the statistics. For me, every map was a story and a virtual journey. Indeed, maps were truly my first expedition vehicles, taking me on grand exploratory trips far beyond the bounds of our neighborhood. Maps are completely full of possibilities to children. Listen to Charles Marlowe, the narrator in Joseph Conrad's masterpiece, The Heart of Darkness. Now, when I was a little chap, I had a passion for maps. I would look for hours at South America or Africa or Australia and lose myself in all the glories of exploration. At that time, there were many blank spaces on the Earth, and when I saw one that looked particularly inviting on a map, but they all look that, I would put my finger on it and say, when I grow up, I will go there. The most memorable and important portrait of our planet appeared when I was 17. Taken on Christmas Eve, 1968, from the Apollo 8 spacecraft as it orbited the moon, Belle Anders' photograph, Earthrise, was published in Life magazine's 100 Photographs That Changed the World. It has been called by many the most influential environmental photograph ever taken. It certainly was a strong influence on me, firing my passion to somehow get to see the entire world and understand that stunningly beautiful orb rising above the lunar horizon. Research tells us that love for science can be sparked by loving an object. A microscope, a butterfly, a toy train, a tide pool, or maybe a map. MIT professor Sherry Turkle, a scholar in the social study of science and technology, writes that objects are not the only path into scientific creativity, but they are one powerful path. She encourages us to put children into an object-rich world, providing things to think with, to connect to, and interact with. So let me pose to you the question Professor Turkle asks her students and colleagues. Was there an object that you met during childhood or adolescence that had an influence on your path into science? Did you become fascinated with how something worked or how it looked? What was the object that moved you towards science? I'm surely not the only one in this room that answers maps. Cartographers were notable figures in ancient times. Attempts to describe the known world figure prominently among our earliest recorded histories. Pomponius Mela's first-century world map, which you see here, includes more than just observable figures, though. Mela includes places of legend and myth, flora and fauna, religious references, and even imagined journeys. Some early maps included fantastic creatures such as elephants, walruses, and serpents to indicate areas or animals as yet unknown to most people. Cartographers marked areas that were not yet documented terra incognita, unknown land. Bursting all of our bubbles, I will point out the dramatic warning, "Here be dragons," colorful phrase found on maps and fables, in fact, has only been documented on one actual surviving map. I guess like the X that marks a treasure site for Indiana Jones or Captain Jack Sparrow, it's a better dramatic device than cartographic method. Where Mela's first-century map included the spiritual and the fanciful, Ptolemy's world map from the early 15th century represents only the known world, divided into 3 continents, Europe, Africa, and Asia. This world is covered with an imaginary grid of parallels and meridians, which Ptolemy called longitude and latitude. According to Professor Francesca Fiorani, to whom I'm indebted for these early images, the Ptolemaic grid map marks the origin of modern scientific representations of the Earth. Early globes, both terrestrial and celestial, were works of art with scientific value on the side. The oldest globe that survives is this one, the Benheim globe made in Nuremberg, Germany in 1492, before news reached Europe from the voyages of Columbus. The age of exploration that followed Columbus's return changed maps dramatically. Bartolomeo Diaz rounded Africa in 1488. John Cabot visited Newfoundland in 1497. Vasco da Gama went to India in 1499. Both Christopher Columbus and Amerigo Vespucci went to South America. The Rosselli world map of 1507 used a new projection that communicated the shape of the Earth and much of the new information from these voyages in an unbroken panorama. In the second half of the 16th century, Duke Cosimo I de' Medici, the ruler of Florence, created a room of maps in the Palazzo Vecchio. The cosmos was depicted on the ceiling, and the walls were covered with panel maps of Europe, Asia, and Africa, as well as images of plants and animals and portraits of famous people. In The Marvel of Maps, Professor Fiorani writes that this room represented, quote, the Earth as seen from above, though viewed from its center, thus generating the simultaneous experience of being inhabitants of the Earth and outside onlookers. This certainly strikes me as resembling the experience I had aboard the space shuttle, and I think it's a perspective that would resonate with everyone who has ever marveled at the Earth from orbit. The maps in the Medici Sala delle Carte were painted on cupboard doors. Opening these doors, Renaissance visitors would find beautiful objects from the region depicted on the map, many of them from the Medici family collection. Sounds rather like a 16th century version of Google Street View or Panoramio, don't you think? See the world from above, then with the click of a mouse, or in this case, a cupboard door latch, zoom in for a closer look at what somebody found there before you. Remember that these 500-year-old images of Earth were drawn by earthbound people. Their individual experience could only encompass the smallest part of the planet's surface. Nonetheless, as Dennis Cosgrove remarks in Apollo's Eye, they were somehow able to grasp the whole of the Earth as a surface or a solid body, to locate within it infinities of space, and to communicate and share images of it. My own first experience with map making came in the second grade. We were to draw a map of the route we walked to school. This simple exercise opened a world of visualization and expression to me. Listing the streets, turns, and memorable points along my path was easy. Picturing how each segment related to the others, what the precise angles were of the bends and corners in my path, and figuring out how to represent these faithfully on paper, those were intriguing challenges indeed. I faced even greater challenges still when I turned to making scientific maps in college and graduate school. As part of my doctoral work at Dalhousie University in Nova Scotia, I mapped a place I never actually saw, the seafloor of the Newfoundland Basin. This area was poorly documented both bathymetrically and geologically, revealed by only a few tracks made by ships that were transiting the area to other destinations. To map the area properly, I had to plot and interpret sonar records collected along hundreds of miles of survey track. This was no small feat in the pre-GPS era, when accurate positioning far from shore was quite a challenge. One bit of great fun, I would add, that this earned me was the privilege of naming some underwater mountains, the peaks in the Newfoundland Seamount groups, that sort of dark cluster just to the right of the orange of the Grand Banks, where you can perhaps see the white number 4,000. Years later, many years later, when I moved into the chief scientist's office at NOAA, I found a detailed map of the world's surface relief covering one very large wall, a gift left behind by my predecessor, Dr. Sylvia Earle. I was delighted to discover that it showed the survey tracks that were the basis for the oceanic bathymetry, and proudly wrote in my Cruz numbers alongside the lines that I had surveyed and labeled each of the seamounts. All of these map-making experiences sharpened my vision. That simple second grade map required that I look at details I had missed in my daily walk to school. The Newfoundland Basin Project challenged me to master remote sensing and map-making technologies that would let me comprehend a major region of the Earth that was then invisible to us by any other means. As the end of my doctoral work drew near, I found myself contemplating an even more remarkable and tantalizing prospect, that of looking at the Earth myself from space as a space shuttle astronaut. True confession, this was really the main reason I applied. My very first glimpse of Earth from this amazing vantage point came 8 minutes and 34 seconds into my first mission. When our main engines cut off as planned, I finally dared to lift my gaze up from the instrument panels in front. A stunning arc of blue and white filled my entire field of view. It quite literally took my breath away. Unfortunately, it did not render me speechless. Stunned by the sight, I blurted out, "Wow, look at that!" Rather bad timing, it turns out, as we were not quite done with some critical items in our ascent checklist. I heard myself a nice sharp bark from the commander for that one. I had the privilege of flying 3 missions aboard the space shuttle, logging more than 530 hours and 8.6 million miles in orbit. The official technical objectives on every one of my missions involved looking at Earth. We conducted a wide array of scientific observations, from synthetic aperture radar mapping of terrestrial and ocean features to collecting detailed measurements of the chemical and physical properties of the Earth's atmosphere. The experience of viewing Earth from space was truly transformational. I could absolutely never tire of looking out the window. On my first shuttle mission, as Michael said, I spent 3.5 hours outside on a spacewalk, or extravehicular activity, EVA for short. Now, no window framed my view of Earth at all. The planet was simply there before me, sliding between my boots when I looked down. That's me on the right. And filling my view in every single direction. The temptation to let the stunning vista distract me from my work was huge. I felt a bit like Odysseus tied to the mast of his ship so he could hear but somehow resist the song of the sirens. In T.E. Lawrence's rendering of Homer's Odyssey, Ulysses comes back from his voyage with spirit gladdened and riper in knowledge for having dared to listen to the siren song. I certainly returned to Earth that way, more curious than ever and completely devoted to finding ways to apply our still fairly new ability to look at Earth from space to the challenging questions of our times. Pioneering environmentalist James Lovelock suggests that the greatest consequence of space research is that the view, and I quote, "from outside our azure green planet in all its global beauty has given rise to a whole new set of questions and answers." Questions, huh? We sure have plenty of those. But how do we get answers? One very important way is by looking at the Earth from space with electronic eyes. Our modern-day remote sensing capabilities are the fruits of many decades of national investment in research. Research that gave us deep understanding of the fundamental physics of electromagnetic energy and its interaction with various forms of matter, of Earth systems and their dynamic interactions together, of sophisticated mathematical modeling, and of advanced computing methods. And what are we able to do with all of this capability? Map land cover types across the entire globe almost instantaneously. Measure the speed and direction of surface winds over the vast expanses of the world's oceans. Monitor the Earth's energy balance. Track ocean currents, map nutrient abundances. Measure the chemical and physical properties of the atmosphere. And make much better maps of seafloor topography than I ever made from a ship without putting anything into the water. So why does this matter, you ask? What's it to you? Space-based Earth observations underpin our ability to learn how our Earth works. More importantly, to predict what it will do next and to harness this knowledge for human benefit. We all profit from this capacity every single day. Consider the value of reliable weather forecasts and early warnings of hazards such as hurricanes, major storms, floods, or tornadoes, so well and so tragically demonstrated in this record-breaking year of weather-related disasters. Or the value of having reliable global inventories of natural and agricultural resources. Consider the remarkable ability to flip from a beautiful panorama like this one to a view that reveals the biological productivity of the ocean. These are but a few of the examples I could choose to make the case that space-based remote sensing is an outstanding instance of science and understanding put into practice and shared freely for, as Francis Bacon suggests, the benefit of life on Earth. This remarkable capability has arisen in our lifetimes, and thanks largely to investments in research and development made by this country. I think it not too great a stretch to say that this is our era's Promethean gift to mankind, a gift that rivals the gift of fire, which legend says Prometheus gave in ancient times. Despite all of these capabilities, however, our ability to carry a digital globe around in our pocket nowadays, we do seem to still be asking largely the same quintessentially human questions. Where am I? Where is my place, distinct from your place? We struggle still with some of the same challenges that faced 15th century cartographers. Is the only goal of our effort representational accuracy? That each place on the map be distinct from all others? That location and distance be plotted with mathematical precision? Isn't something more required if we are to achieve deep understanding of our planet and ourselves? Last month, the 24th General Conference on Weights and Measures met in Paris to finalize state-of-the-art indisputable definitions for basic units of measurement, including the meter, the second, and the kilogram. Writing in the New York Times, philosopher Robert Cruz suggested that we are infatuated with measuring objects or properties on a scale or with a ruler, focusing on carefully calibrated details. He laments that we are less able, or at least much less apt, to measure ourselves ontologically, that is, based on experience. When we're participating or observing firsthand, we sense when things don't measure up to what they could be. More often than not these days, according to Dr. Cruz, though, we avoid qualitative analysis and assign too much meaning to quantified measures. Today's geographic information systems certainly give us the ability to look at the Earth in quantitative ways with unprecedented speed and ease. But this is not the same as looking at the Earth more insightfully or integrating our experience and assessing context and consequence. Again, Professor Fiorani reminds us that the latter is precisely what Renaissance cartographers did. She states that Renaissance mapping was an enterprise integrating textual analysis, computation, and visualization, to which scholars, artists, merchants, and patrons contributed, working side by side. In that same vein, Neville Fenneman, president of the American Association of Geographers in 1919, described the need for geographers to assemble facts from diverse fields, facts joined together by the sole bond of a common locality, and called for the examination of the interplay of physical, social, economic, historical, and other data of, quote, distinctly human concern. He urged geographers to embrace their role as integrators across the boundaries of disciplines, a call that is even more relevant some 90 years later. Nowadays, GIS technologies do indeed bring together remote sensing scientists, geographers, land use planners, unimaginable to early cartographers. Just as in ancient times, however, the challenge of giving meaning to this analysis and developing deeper understanding calls for further, richer, more collaborative study across, or perhaps the percentage of people that participated in the latest census, county by county, or zooming further in, maybe a map that reveals the type and frequency of crimes committed in various areas of a city. These new ways of looking at Earth both reveal what is and help us understand the connective tissue that binds together the natural, political, and social dimensions of our experience. As in ancient times, so today, our digital cartographic tools are used to organize information about property and power, whether that's determining tax rates or apportioning political representation districts. We can amass volumes of data and process it with a speed unimaginable to early cartographers. Just as in ancient times, however, the challenge of giving meaning to this analysis and developing deeper understanding calls for further, richer, more collaborative study across many disciplines. In the early 20th century, Fenneman's common localities existed as specific, unique physical locations. Today's digital communication has given rise to virtual communities and given new meaning to what constitutes a common locality. A site, a location and position in space, is defined by coordinates that are easily measured by anyone with a GPS. Place, on the other hand, includes what we consider important, how we interact with our world, how we see and understand the environment around us. That GPS we have on our phone or in the car can tell us where we are on Earth at a specific spot on the Ptolemaic grid, our site or our location. But how does this digital world we live in now, this digital globe, how does that impact our sense of place? William Ferris, the former chair of the National Endowment for the Humanities, said in 1996 that each of you carries within yourself a postage stamp of native soil, a sense of place that defines you. And it is to this place that each of us goes to find the clearest, deepest identity of ourselves. Today, that metaphorical postage stamp is often a computer chip, and we can go to that place or any place with just a few clicks. So, do digital technologies help us jump out of our bodies and blast us out of place? Architectural historian Mitchell Schwartzer suggests exactly that. Handheld digital devices, he writes, accelerate the reconstitution of place from real, occupied space to a collage of here and there, past and present. But they also allow us to know more about the space we occupy, accessing information from authorities and from social networks. Schwartz asks, does this accessible information supplant direct engagement with the world, or does it encourage people to engage? In front of a magnificent vista or a remarkable sculpture, why is someone glued to a 3-inch screen with their thumbs flying? Is he or she oblivious to where they are? Distracted? Perhaps our mad texture is reading background information about the scene, or excitedly sharing their experience, their emotional reaction with a loved one. Today, everyone is a researcher and a reporter, armed with a camera phone, searching the internet, texting their description of events. So I ask again, does the eye gadget stand between them and a real experience? Or is it a tool with which they can personalize and enhance the encounter? I certainly hope the answer is both. That through these new digital processes, information passes into vision, that state of mind and heart that does not merely swallow evidence, but changes that evidence into a judgment, an appreciation, a living picture of a place, as Sir Douglas Newbold put it so eloquently. We have countless personal GPS gadgets available today, all designed to keep us on course. Most of us probably use more than one on a daily basis. Some say the fact that we need them now is a sign that we've already lost our way. We are so disconnected from our experience and our environment that we just about need a GPS to get around the block. All-time Jeopardy champion Ken Jennings, a self-avowed geography geek, considers this issue in his most recent book, Maphead. Mr. Jennings told Time magazine that because we are, quote, outsourcing navigation to a little box in the car, we are inevitably going to get lost in the parking lot, if not the grocery aisle. Looking at Earth from ground level through a disembodied voice does not always mean we see it, or that we log landmarks in our memory. I don't know about your GPS, but mine doesn't say, look for McDonald's and turn right just past the drive-thru entrance. Those landmarks are human memory devices. We are much less observant when we navigate with GPS. We seem to hardly know where we are. We only know the destination, and sometimes all we seem to understand is how to follow the next instruction, not whether it makes any sense. We take little or nothing of the journey with us because, as Mitchell Schwartzer points out, the network now remembers for us, just like it remembers all the telephone numbers we used to be able to recall. But at what cost to the richness of our lives and of our sense of the world, of the earth around us? Google Maps puts us just a mouse click away from seeing virtually any location on the globe at a national, continental, or worldwide scale. With one more click, we can plant a little red balloon at our spot on the map and make it our very own virtual globe with ourself at the center of it. Amusing? Certainly. Handy? Very often. But does such easy individuation move us away from the greater vision that American poet Archibald MacLeish put forth back in 1942 when he wrote, "Never in all their history have men been able to truly conceive of the world as one, a single sphere, a globe, on which there is no center because every point or none is the center, an equal earth, a globe in practice, not in theory." Headlines tell us daily the impact of our interdependent economies across the globe. We see the interconnectedness of our environmental problems, getting fresh water where it's needed, maintaining healthy oceans, protecting ecosystems and the very existence of many species, predicting and mitigating the devastation of natural disasters, ensuring a higher quality of life and of opportunity for all of our planet's citizens. Why should we look at the Earth? Many space travelers have observed that from 250 miles up, one sees no fences, political divisions, borders. All of our human squabbles and differences are unseen in the remarkable images of Earth we have from space. As idyllic as this view is, the fact is that all is not well with our planet. With electronic eyes perched above the atmosphere, armed with technologies to see, define, and measure aspects of our planet, we can and must go beyond awe to action. It is imperative that we sustain the means for monitoring, studying, learning about, and protecting our planet and its natural systems, that we not let our Promethean gift be lost. Yet blue ribbon panels have cautioned for years that we are allowing it to erode, and the financial strains now affecting the developed Western nations cloud the outlook even further. Are we falling behind in a world we created? Or are we simply witnessing a pattern change, a shift to a new set of global players and a new organizational paradigm? Technological capacity is certainly growing worldwide, and surely this is a salutary development. The balance of power will certainly shift among nations as a result. Then there's the movement from centralized problem solving to crowdsourcing, to amateurs armed with digital technologies, becoming experts. Can this evolve to providing the scope, scale, speed, and accuracy of global observation that today's scientific capabilities require? Or will this bring questions of authority, reliability, and continuity, similar to those that we face today with the internet? And can those be resolved? I say that we must not let our capability to look at Earth from space erode. In this era of burgeoning population, increasing competition for decreasing resources, and clearly evident strains on our planet's natural systems, the need for Earth observations, science, and information services has never been more urgent. We must somehow start a new conversation about looking at Earth. Who will raise up a sign that says, "Occupy Earth," and lead that movement? For all of our efforts to truly see the Earth, we have as yet had only a glimpse. We sitting here today know more about planet Earth than humans at any other time in our history. Yet in many ways, we know less about it than we do about the moon. As we wrestle with the complex environmental, political, and social challenges of our times, it is clear that we don't yet know enough about our planetary home. More voyages of discovery are clearly needed, and urgently so. In 1947, geographer and cartographer John Wright said that we had filled in every geographical gap with sound, if incomplete, knowledge. He suggested that there was, quote, "no place now in the shadow of total human ignorance," but went quickly on to add, quote, "there is no terra that is absolutely cognita." Let me repeat, there is no terra that is absolutely cognita. We have so much more yet to learn. Do you know this planet? That little blue marble on the left, do you see yourself in this image? Do you see your family, your home? You should, because each and every one of you is in this picture, taken from Mars by a European space program. I think Anne Morrow Lindbergh said it best in the early days of the space age. No one will ever look at Earth the same way. Man had to free himself from Earth to perceive both its diminutive place in a solar system and its inestimable value as a life-fostering planet. We can see our planet with detachment, with tenderness, with some shame and pity, but at last, also with love. In that spirit, I say to each of you, look at Earth and look after it lovingly. Thank you.